Assalamu alaikum everyone. This is Dr. Drakhterraza. I welcome all of you in Data Science Workshop series. This is second lecture about the data visualization. Last lecture was about the data collection and the data cleaning. Today we will discuss the graphical representation of information and data by using the visual elements like graphs and charts. Data visualization tools provide an accessible way to see and understand the trends, outliers, and patterns in data. It provides an excellent way for researchers or the business owner to present data to the non-technical audiences without confusion. Data visualization is crucial as it transforms the complex data set into intuitive, visually compelling formats, making it easier to identify the patterns, trends, and outliers. It enhances the comprehension, enabling the quicker and the more effective decision making by presenting the data in a way that is accessible to the both technical and non-technical audiences. Moreover, well-designed visualization can uncover the insights that might be missed in raw data, facilitating the better storytelling and communication of findings, which is essential for driving informed business strategies and research outcomes. Visualization tool. Very important tools are Tableau, Power BI, Google Data Studio, Excel, CoreR, ggplot. CoreR and ggplot, these are the two important functionalities in R. I will discuss the CoreR to keep the lecture as simple as possible. There are the many other tools. One of the very important tool is the click view. MicroStrategy is also providing us a tool for visualization. Interactive visualization create interactive dashboards with drag and drop functionalities. Data connectivity. Power BI provide us the very large connecting sources. We can include the CSV files, the Excel files, we can include the web data, we can include the databases from Oracle, Microsoft SQL Server, and the other tools as well. So one of the very important aspect of Power BI is the visualization is very important. If you click over in a visual, then the remaining rest of the visuals in the report will be adjusted automatically according to your clicks. This type of visualization is a very comprehensive and interactive. Data modeling is also an important feature of Power BI. We can make the connection between the tables. We can create relationships among the different tables. This is called data modeling. Custom visuals can also be included. Real-time data can also be reflected in our reports. Another important feature is the natural query language. We can have the query language to update our visuals according to our instructions. Mobile accessibility, collaborations with the other tools like R. We can connect the R with the Power BI. We can connect the Python with the Power BI. This is one of the very important feature of Power BI. ggplot2. ggplot2 is an external library in R. We can download the library and integrate the library in R and use the several functions of ggplot2. The important aspect is customizable theme, layered approach, faceting, aesthetic mapping, statistical transformations, extension, integrations. Different elements can be accessed by using only one command. That command is ggplot command. I'm not using the ggplot for this presentation. I will discuss only core R. Core R because I want to keep the code as simple as possible. What important graph we are discussing in this presentation? The bar chart, the pie chart, box plot, histogram, density plot, scatter plot, heat map, line chart, tree map, dendrogram, and time series plot. Some of the graph I will discuss in detail, but remaining you can download the code from my website to discuss it. Due to the time constraint, few of the graph I will not discuss it in this presentation. Which file I will use? I used in lecture number 1 Toyotocorrola.csv file. The dealer sells the used car for the small profit. To ensure a reasonable profit, the dealer need to be able to predict the price of the dealership will get for the used car. The Toyotocorrola file, I will use the Toyotocorrola file. We have eliminated the outliers, the missing numbers, the duplicate rows, and the other bugs from the data in my last lecture. In the clean file we will be using for the purpose of visualization. The 3 steps we did in the last lecture. This is the structure of my data file. It contains the 39 variables and 1445 rows, including the sum of the rows have NAs, including the sum of the rows have missing numbers, including the sum of the rows are replicates, and outliers. So we can, before using this file, we have to do the 3 steps which we did in the last lecture. One of the step was removing the missing numbers, removing the replicated rows, and removing the outliers. Firstly, we will read the data file by the command read.csv. In a data frame, name of the data frame is cardef. The cardef, we will use the structure of the cardef for the rest of this lecture. This is the structure. We can create the box plot, histogram of the price column because it is our main dependent variable. We can also create the box plot, histogram of the different fuel types car for prices. We can create the scatter plot between the price, kilometer, horsepower, the number of doors, the number of cylinders, the weight, because these are the numeric variables. We will use all of the numerical variables for the purpose of predictive modeling in the next lectures. What is a data frame? A data frame is like a table in Excel. We can extract its variable with the $sign. This was discussed in the last lecture. Data frame, $sign, the column name. If you want to use the price column, then price column can be used by cardef $price. Entire the price column will be used in the command where I will use this specific pattern. Graph of the missing cases. This is the first visualization that I am going to describe here. Missing numbers can be represented by using a package. The name of the package is Viz data package. Firstly, you have to install the package by the command install.packages Viz data. Then you have to include the library in R. So what is the difference between these two commands? The first command, download the package from the external source. You must have an internet connection before installing the package. The second step is to run the package by using the library command. There are the two main commands which can display the missing data in my data frame, cardef. The one of the command is vismiss, and the syntax is quite simple. Just write down the vismiss, and in the parameter you have to identify the cardef. The cardef is my data frame. It has 39 columns, and there are only 2 columns which have the missing numbers. So this command will show you the missing numbers by dots, by black dark dots. Wherever you have the missing number, a black line will be shown over there. The second command is visdata. Visdata command represent the data types of each variable. So what is the difference between the visdata and the vismiss? Vismiss will not show the data types, while visdata along with the missing data will show the data types as well. So this is the output of vismiss. You can see these dark lines which indicates the NAs in my data, missing numbers. There are the 2 columns. The column price have missing data, 1% data is there, and another column is a kilometer column. We have 3 or 4 missing data elements in the kilometer column. The missing data by dark dots or by the blacks, and the gray is indicating that we have the data over there. So 99.9% observations we have the data, but less than 0.1% element we have which are missing in our data. So these are the missing numbers in my data set. The next output is the output about the visdata. Visdata indicate and includes the data type of each of the variables. So this is the output of the visdata command. You have just to provide the name of the data frame inside the bracket, and the same missing numbers are there in the 2 columns. One is the column of kilometer, another is the column of price. The next thing which is here in the output is the red color. Red color means the variable, first 3 variables, model, the fuel type, and the colors. These are the character variables, and the rest of the variables we have integer variable, which is indicated by the blue color. And the third thing is a gray color or a black color, which indicates the NAs. So there are the 2 data types. One is the character data type, other is the integer data type. Some of the variables are character and the rest of the variables are integer. So this is an indication of visdata. The visdata and the vismiss, these are the 2 commands that you can use for identifying the missing numbers graphically. Removing the missing cases. This was explained in my last lecture, how the missing cases are represented in my data file. This is a very important question. And the second question is how missing cases are eliminated. Second question is it. These are the 2 questions which we addressed in the last lecture. Missing numbers are represented by NAs in most of the data types, in most of the data files. And we can remove the NAs by na.omit command in R. The very simple command is na.omit cardef. Cardef has 2 columns in which we have the missing data. One is the column of price and other is the column of kilometers. These 2 columns have missing numbers, which was indicated in my vismiss and visdata commands in the previous 2 slides. After removing the na.omit, I will show you the structure again so that Now we have 1428 observations. It means some of the rows are eliminated. Actually it was 1445 rows, now it has 1428 rows. The number of columns are same, 39 columns. Still we have, so after removing the NAs. Another option, if we don't want to omit the missing number, is the option of imputation. We can use the mean imputation or the median imputation by the rest of the available observation and fill that mean to the missing places. This was discussed in my last lecture. 17 rows removed from the CARDF. Other than the NA.omit, what are the other options? As I told you, the other options are imputation. Or we can also use predictions. We can use linear model for predicting the missing numbers as well. The next is the type conversion. Type conversion means there are the two variables. One of them is a fuel type variable and the other of them is a color variable. These two variables are non-numeric variables. We can convert these two non-numeric variables into factors because these are categories. These are not a string, these are categories. So every categorical variable can be converted into the factor by using either as.factor command or by using just factor command. The fuel type and colors. The factor variable, factor command, and the variable name is CARDF3 of fuel type. CARDF3 fuel type. The fuel type will be converted into the factor and stored into the same variable named as fuel type. The fuel type is a variable. Before this command, the type of the fuel was character, and after this command, the type of the fuel type variable is factor. The next command is to convert the color variable into factor by using this statement. Factor CARDF3 color, and the same variable will be used for the storing purpose. So this is very important before making any of the visual of these two non-numeric variables, to convert them into the factor, because we cannot use the simple string variables for the purpose of bar charts and pie charts. The structure before conversion, fuel type is indicated as a character and color is also indicated as character, and in double quotes we have, in double quotes means strings, basically it is a string. And after conversion we have factor with 3 levels. What these levels are? CNG, the diesel and petrol. Every element has a digit, 2 second, 1, 2, 3. These are the codes which will be assigned by this command to the fuel type variable. Now the second thing is the structure of color variable. Now we have the 10 levels. 10 level means the 10 different colors we have in this data file. So we have to identify the colors. The colors are very important, and these 10 colors are converted into the factor. The next element is the removing the duplicated rows. Duplicated rows, there are the several rows which are replicated in my data file. We have to eliminate them by using the duplicated, by using the replicated rows or by using the duplicated function. The duplicated function do what? Duplicated function indicate the true and false structure of every L row which is replicated. If a row is replicated, then it represents a true. If a row is not replicated, it represents a false. Finding the total number of duplicated rows can be done by this sum duplicated cardf. This will do what? This will calculate all the duplicated rows in my cardf data frame. So there are total 9 rows which are replicated in my cardf. So the output of the sum command is what? It indicates 9, meaning that 9 rows are replicated. After removing these 9 rows, we will show you the structure of the command again, structure of the cardf again. Before duplicated rows, we have initially we have 1445 observations, and we can make a frequency table of the duplicated rows. So how we will specify this frequency table? By the table command. The table command and the cardf data frame, duplicated rows, and the gain data frame name is to be used here, column number 1, because duplicated rows by column number 1, which is the car ID. So if a car have ID 7, so the 7 car, if we have a 2 times of the car 7, then column number 1 indicate us duplicated rows, right? Next step is to remove the duplicated rows. This is the output of the table command. Row number 9 is replicated 2 times. It means we have the 3 versions of the row number 1. First one is the actual row number 9, and the 2 replicates we have. We have 1 replicate of row number 16. It means the 1 of the row is the actual row, and 1 replication of row number 16 we have. So this is an indication that totally we have 11 rows as replicated rows. So we have 11 rows, 9 rows. I'm sorry, it is not 11, it is 9 rows we have replicated. If we want to remove these replicated rows, we should use the unique function. The very simple format is unique cardf, and the cardf is again stored in the same data frame. So only the unique rows will be moved to, and the 9 rows will be removed after this command. So actually we have 1445 observations of 39 variables. After removing, we have 1436 rows of 39 variables. So this is the structure we will use for the purpose of making bar charts and the pie charts. Factor variables can be represented by bar chart and the pie chart. Finding the number of vehicles by the fuel types, table command. Fuel type, cardf, and the table is stored in VEHF type variable. Because bar chart and pie chart needs a table. So we must have a table, and that table will be the argument of bar chart and the pie chart. The bar chart command, I will provide the vehicle F type, the new table created by the previous command, into the bar plot. This will do what? This will create a bar chart of vehicle fuel types. So there are the 3 fuel types: the CNG, the diesel, and the petrol. And how many cars are on CNG, how many cars are on diesel, how many cars are on petrol? This is an indication by this plot. If we want to include a title over this graph, So we can use an argument main. Petrol cars, around 1200 cars which are on petrol, around 200 cars in my data frame on diesel, and a very few cars are on CNG. So this is an indication of a bar chart. The data of the fuel types can be represented. This is a table, frequency table represented by the bar chart. The main command will provide us an option to place a title over there. So if you want to place a title over there, to use the main function. The bar plot, instead of closing the bracket here, just place a comma and the number of vehicles used as a title. The number of vehicles by their fuel types. So the output will be this title will be represented by if you want to include the label, X label and the Y label, so you have to use X lab and Y lab parameter into the bar plot function. So we have the option of X label, the label is fuel type, Y label is the number of vehicles, and the main, the number of vehicles by their fuel types. So this is the bar plot command with the extended functions. In every graph we can have X label, the Y label, and the main by the same feature. And the output will be what? This is your X label, fuel type. This is your X label, this is your Y label, and the title. The three elements are there. You can include the colors because we have the fuel types, 3 different fuel types. So we can introduce the color options of 3 different colors for each of the element of this bar plot. So 0, 5 and 9. I choose the 3 color codes. These are the color codes 0, 5 and 9. How can we introduce the color? By the call function. Call means color. Color car df fuel type. In the square bracket I use these 3 elements 0, 5 and 9. Color 9, color 0, color 5. So 3 different colors will be used. It is a dynamic coloring, not a static coloring. The output is what? Output is, this is the output. Petrol cars are represented by another color, the diesel is by green, and the CNG by another option. We have. Now, pie charts. Same function can be used. But you can include one additional feature. This is the radius. By default, the radius is 0.8. If you want to make a big circle, then it can be more than 0.8. So you can, I use 4 as the radius. The main title is the number of vehicles by their fuel types. I use the rainbow color here. The different colors will be used for the vehicle types. The output is this. Most of the cars are on petrol. Some of the cars are on diesel, and CNG is represented by the red colors. And the title is over there. Similarly, you can use the X label, the Y label function with the pie chart as well. How to generate the graph in a separate window? This command is X11. X11 will generate a separate window. Then the subsequent plotting command will be represented in this new window. And if you want to split the window into segments, then PAR MF row. PAR stands for parameters, and we are defining a parameter MF row. 2 by 2. It means your graphical window will be bifurcated into a 2 by 2 screen. A new window, and it is bifurcated into a 2 by 2 window. The first plotting command will display the output here. The second display command output here. The output of the third plot command will be here, and similarly the last output will be here. These 4 segments will be used for the next 4 subsequent commands. If you want to split this screen, this new window, into 3 by 3, just number of rows 3, number of columns 3. So instead of a 2 by 2 window, we will have a 3 by 3 window in that. Four commands: bar plot, fuel type, pie chart of fuel type, bar plot table, and the bar plot color. These subsequent 4 commands will display the output in the previously created new window by X11 and bifurcate it into the 4 segments. The output is this. You can create the box around the each of this graph. If you want to create a box here, so you have an option. This can be created by using a box function. So the next command is X11 will do what? X11 will create a new window. PAR MF row will generate the output into the 2 by 2 window. 4 graphs can be printed. The first command, bar plot, will display the output in the first segment here. Here will be the bar plot. And then a box is created around it. The bar plot and the bar plot and a rectangle box. Similarly, a pie chart will be generated in the second window, and then a box is created, and so on. Third command and the fourth command. The 4 boxes will be represented here. Plotting line, rectangle, text, circle on an existing plot. We can write text as a title of the graph, or we can type a text inside the graph still. So there are the further options we have with the text command. We have to specify the position by identifying the row number and the column number of the screen where the text start. So these options we are going to enhance in our visualization examples. This command will do a new plot, blank screen with the x-axis scales of -3 to +3 and the y-axis scales to -3 and +3. So what is -3 colon +3? It indicates from -3, -2, -1 and so on. So this new window will be like it. We have a blank window in which 0 is in between. Then we have a -1 and -2 and -3. Then we have +1, +2, +3 on the x-axis, as well as on the y-axis we have 0, -1, -2 and +1, +2, +3. Over this new window we can plot anything. but that thing will be in between the scales of this window, and the scale is from -3 + 3 and -3 + 3. So within the scale we can put a circle, we can put a rectangle, we can draw anything else, or we can write down any text in between these two scales. To draw an empty graph with the scale of x-axis and y-axis in between -3 and +3, and then a new blank window will be displayed on the screen. AB line. This command will draw a straight line. It has the two options. Either we can specify the horizontal value, or we can identify a vertical value. Any one of these two can be specified. Or we have the option of identifying intercept and slope. So these are the 4 parameters, and any one of the 4 parameters can be used. Intercept can be used, slope can be used, B is the slope, H is the value of the horizontal line, means it's a y-intercept. So we have to specify a y-intercept here. Over this place, y-intercept is to be specified. Then the horizontal line will be printed. And this is an x-intercept. The value you are mentioning here, v is equal to something. V is equal to something means we have to identify the x-intercept. So these are the 4 options. You can any of the option in drawing the line. If we want to draw a horizontal line parallel to the x-axis, means y-intercept is 0. So this command will do that. Draw a horizontal line which is a long x-axis and the y value is 0. So what command should we use? The command is this. And this command will identify h is equal to 0. H is equal to 0 means horizontal line, and the y value is 0. This is the value of the y-axis. Color is red, line width is 4. LWD means the line width. A line is drawn with the red color. Then a text is written just above the line. From starting point is from -2, 0. -2, 0 means the value of the y-axis is 0 and the value of x coordinate is -2. And this is the text that we want to display. Is the name of the line, AB line with the y-intercept 0. And the line was drawn by the red color. The text is also mentioned with the red color. And few adjustment is there, 0.5 minus 0.5. If we do not use adjustment, then the text will be overwritten on the line. If the text will be on the line, then it should be like it. AB line, like it. AB line with y-intercept. So we don't want to write down the text exactly over the line, just below or above the line. So these are the 2 adjustments which we did. Then another line is drawn, horizontal line at x is equal to 1. Not x is equal to 1, at y is equal to 1. This is the y coordinate. And this line is of the blue color. The first line will be at 0. This was the 0. The first line will be this. The second line will be drawn at 1. Y value 1. Y value 1 is this. The second line will be drawn here. And this is a blue line. Not a red line. This is a blue line. A text will be overwritten AB line with y-intercept is equal to 1 because the value of the y-intercept is 1 here. And the color of the text is blue. The blue text will be written over there with the same adjustment. Now if we want to draw another line with the y-intercept of -1, color is green, line width is again 4. This is the width thickness of the line. And this line, the text will be written over -3, -1. AB line with the y-intercept -1, color is green. Output of these 3 commands will be shown over the next slide. This is the output. This is the horizontal line with the y-intercept 0. This is also a horizontal line with the y-intercept 1. And this is the horizontal line with the y-intercept -1 with the green color. And you can see the text is not exactly on the line. It is just above the line. So these were the output of the previous 3 AB line commands with the text. Now we want to add some vertical lines over it and few diagonal lines as well. So adding the vertical lines in it, we have to use a parameter v is equal to something. This is the command. This time I am not using the v is equal to exactly one number. This time I am using a range. V is equal to -3 colon plus 3. What it does? It will generate a series from -3 up to +3. Means a vertical line will be drawn at -3, then at -2, then at -1, then at 0, then at +1, +2, +3. It will generate 7 lines with the 7 different colors. Color number 1 to 7. Similarly, the line width is 4. X-intercepts. -3 is the x-intercept. The first line have a x-intercept of -3. The second one has a x-intercept of this, and so on. This is the meaning of -3 colon. Colon is basically a sequence operator in R. So whenever you use -3 colon +3, it means a series of -3 plus 3 will be generated. Achha, draw a line having the y-intercept of -2. These are not the horizontal or vertical lines. These are the lines, 3 lines, which has the same y-intercept. Same y-intercept. Y-intercept means what? Y-intercept means where the y-axis will cut. So this is -1, this is -2. So this is the point which I referred in these 3 lines, -2. The first line have a slope of 3, the second line has a slope of 2, and the third line has a slope of 1. So the slope of all of the 3 lines will be drawn from this point, but the slope of all of these 3 commands is different. So the output of these 4 commands, actually these are not the 4 commands, these are the 7 commands which generate the 7 vertical lines, and 3 more lines will be added over the previous 3 horizontal lines. So the output will be, this is the output. The original 3 horizontal lines, these are. Then 7 vertical lines at x-intercept -3, -2, -1, +1, 0, +1, +2, +3. And then 3 diagonal lines having the y-intercept. This is y-intercept of -2. So you can see that this is -2. X coordinate is -2. And the slope of all of these 3 lines are different with the different colors. So this is an indication that you can use any line with any color with other options, right? The next is making the histogram and the box plot of any quantitative variables, because bar chart and the pie chart. These are the two graphs for the factor variables. But if we have quantitative variable, scaled variable, if we have the scaled variable means numeric variable. If we have a numeric variable num or int, it may be int in R, integer. For the numeric variable, we can create the histogram or the box plot. It is a univariate analysis. For one variable, we can construct the histogram. For the same variable, we can construct the box plot. The commands are very simple. The hist command, HIST. Hist command will generate the histogram and the name of the variable inside. And the box plot command for creating the box. Hist command, you can see the hist command here. Hist command, cardf dollar price. Because in R, one column can be represented with the help of $sign with the data frame name. Histogram will be generated by this command. Then box plot, the same command. We have the same variable with the command box plot. But this box plot will be generated vertically. If you want to draw the box plot horizontally, then you should have to add one more parameter here. And that parameter is called horizontal is equal to true. Horizontal is equal to true will display a horizontal graph. Horizontal box plot. Now this is the output. You can see the histogram, and on the next slide you can see the box plot. What this histogram is indicating? This histogram is indicating that the distribution of prices is not normal. So the question is what? Is it bell-shaped? The answer is no, this is not bell-shaped, because it has a distribution which is like it. We can call such distribution as positive skewed distribution. This is a positive skewed distribution. Means it is not normal. Positive skewed distribution. Or we can call it as a right skewed distribution. It is not normal. Now the box plot is also indicating the same thing. What this is indicating? The right whisker is longer than the left whisker. The box is called a right skewed curve. So you can have the same distribution here by the box plot, and the box plot, you can see the box plot is horizontal, not a vertical box plot. So what are the elements of these box plot? In the previous lecture I explained the elements of the box plot. These are the outliers in my box plot. These points are referred to as the extreme numbers. The next thing is the left edge of the box is called first quartile. So this is quartile 1. The second one is referred to as quartile 2. This is quartile 2. Quartile 2 is also referred to as median. And the third point is referred to as third quartile. 75% observations are below the third quartile. Below the third quartile, 75% observations are below that. And 50% observations are below the second quartile, and 25% observations are below the first quartile. The quartiles can be identified by using the corners and the midpoint of the box. Another thing is the width of the box. The width of the box is referred to as interquartile range. Interquartile range can be determined by the difference of third quartile and the first quartile. The formula of IQR is Q3 minus Q1. Q3 minus Q1 is called interquartile range, IQR. And the left edge is referred to as left whisker and the right edge is referred to as right whiskers. So these are the elements of the box plot. This helps us to identify whether the distribution is a symmetric distribution or a negative skewed distribution or a positive skewed distribution. Another thing is outliers can also be determined with the help of the box plot. Now we can construct the box plot of car prices for each fuel type. So we can add one more parameter here, fuel type parameter, and that fuel type parameter, because we have the three different types of fuels, CNG, it has three levels, CNG, petrol and diesel. These are the three levels of fuel type, and we have already converted the fuel type from character to factor, which is necessary for creating the box plot in this way. So a new window, graphical window is generated by X11. Then box plot is generated. You can see with a different command here, and that command is we have a sign tilde. This is very important sign in R. This sign is used to identify the formula. What formula is this? In this formula we have dv before this sign. This is my dependent variable, the box plot of prices we want to generate. And after the formula we have IV, this is my independent variable in this example. And this IV is a factor IV. It has three levels. So one box prices of fuel cars, prices of diesel car, prices of CNG cars. So three different box plots will be generated by only single command. So this is the beauty of the formula. If you are using the formula, then you can identify, but the formula is not allowed in all commands. Box plot commands support this, and you should remember whenever the formula is given, this sign, tilde sign, it is the upper left key on my keyboard. So this sign should be used in a formula. Horizontal is equal to true means three box plot, all horizontal will be displayed on a new X11 window. X11 window means what? A new graphical window is generated, and in that new window three box will be displayed. These are the three box. This is the box plot of petrol car prices. This is the box plot of prices of diesel car. This is the box plot of prices of CNG cars. You can see that it has outliers. It also has outliers, but this does not have outliers. And all of the box plots look like as right skewed graphs. What happens if we need a graph which is like a bell shaped? These graphs are not bell shaped. Still, the graph of prices is also, this is not histogram, this is a box plot. The heading is not correct. You can correct the heading box plot. Box plot. We are assuming for some of the statistical procedures, we need the data to be normal. But this data of prices is not normal. So there is a technique in mathematics and statistics, and that technique is called transformation. There are the several purposes of transformation, but one of the very simple purpose is to achieve normality. If the data is not normal, you can achieve the normality. You may achieve the normality by any transformation. And transformation is not any one transformation. We may have a root transformation. We may have a log transformation. We may have reciprocal transformation. So the different transformation we have, and different situations we can apply the different transformation to achieve. So the first transformation objective is the normalization. Normalization means what? If the data is not normal, we can make the data normal by using any transformation. The common transformation for the normalization include the logarithmic, square root, and one of the very popular transformation referred to as Box-Cox transformation. These three transformations are widely used for normalization. Means what? If your data is not normal, if your data is a right skewed data or is a left skewed data, and you want to make the data normal, to try any transformation. Okay? There is no universal rule for identifying any transformation, but hit and trial procedure can be used for identifying the correct transformation for normalization. The second important thing is stabilizing the variances. If the variances of the variables are not same, suppose I have a variable x and another variable y, some of the statistical procedure have assumption that the variance of x and the variance of y should be same. So how can we, and if in reality the variances are not same, then another objective of transformation is to stabilize the variance. Stabilize the variance means what? This is also referred to as homoscedasticity. So homoscedasticity can be achieved by the help of transformation. This is the second objective of transformation. Third important transformation is a linearization. If your data is not linear, if your data is slightly curvical data, if you have, and you want to make the graph linear, the transformation can help us to transform the linear. The linearization is another objective of transformation. Another objective of transformation is handling outliers. Outliers can also be handled by using transforming the data. Very simple transformation for handling the outlier was discussed in my last lecture, creating the z-score. The z-scores can be created by subtracting the mean of the variable and dividing the variable by the standard deviation. Then the data is transformed into z, and all the values of z which are below -3 and all the values of z which are above 3 will be assumed as outliers. So these outliers can be removed. All of the z values which are below -3 and all of the z values which are above +3 can be eliminated from the data. This can be used as a transformation. So z-score transformation, this is called z-score transformation, identifying the z-scores of the variable. The next element is assumptions. Assumptions, statistical assumptions. Statistical assumptions are very important. Two assumptions are already identified: assumption of normality and assumption of homoscedasticity. So you can identify the transformation for if assumptions are not fulfilled, you can transform the data. Normality, linearity, homoscedasticity, transformation help us to ensure these assumptions. If these assumptions are not fulfilled, then transformation help us. In dimensional reduction, we can also use transformation. Principal component analysis is one of the important technique. Very fundamental step of PCA is to transform the data first. Data smoothing, and if you want to remove the noise from the data, this which is referred to as smoothing, transformation help us to smooth the data. So these are the different objectives of the transformation, and names of the transformations are root transformation, log transformation. Either we may have natural log or we may have logarithm of base 10. And reciprocal transformation 1 upon x. Still we can use the trigonometric transformation like sine transformation, cosine transformation, tangent, cotangent transformation. These can also help us in. So this is a trial and error case. Choose one transformation and make the graph again. If the graph is according to the specification, then select the transformation. Otherwise, discard the specific transformation and choose the another one. So this is the technique which we generally use for the purpose of transformation. The next is, my price variable was a right skewed, and I want to apply a root transformation and check whether after applying the root transformation the price variable becomes the normal or not. Then I will apply the logarithmic transformation and check again whether logarithmic transformation is suitable on the price variable or root transformation is suitable on the price variable. So this is to be done by using a very simple command, sqrt function. Sqrt function of what? Prices. So nothing is to be new here. We have a variable of prices. Square root of every price is computed and then stored in a new variable, and the new variable is referred to as RT price. RT stands for root price. This is a user defined variable name. You can use any of the variable name on the left side, but you should remember we cannot have spaces among the variable name. I cannot use RT space price. This is invalid because these are assumed as a two variable. One variable is referred to as RT, another variable is referred to as price. So you should have a name which do not have any space among them. Then in X11, new window is generated, and the new window I want to split the two graphs. One graph is the graph of the actual data of prices, and on the second window I want to draw the graph of the root price, yani price after taking the root, square root. So these two graphs will be generated by the two next command, histogram of root price and the box plot of root price. The both of the two box plot of the root price and the histogram of the root price, these two graphs are generated on the next after transformation. So before transformation, what was the shape, and after transformation you can see. Before transformation the skewness was very strong, but after transformation it becomes better, but still it is not normal. It is not normal, but is better than the before transforming, right? After transformation and before transformation. Then second transformation which I will use is the logarithmic transformation of prices. The same command, but instead of the square root function, I use the log. And in R, the log is a natural log. It is not a log of base 10, it's a natural log. And a new variable is created, and the name of the new variable is log price, LG price. And a new window graphical is generated, and graph is split into the two segments. One is for the histogram and other is for boxplot. Now you can see this is the before transformation, it was this, but after the log transformation, it is much better than the root transformation as well. So it is better than the original data, still it is better than the root prices. The log prices is better than the root prices. So this is the way of searching the suitable transformation for any quantitative variable. These transformations are used for scaled variable. We cannot use the transformation over the string variables. Some transformation can be helpful for factor variable, but most of the time we use the transformations for scaled variable. The next element is the density plot over the histogram. Density plot is what? Density plot means that density, this is the density plot. We can also call this as a frequency curve. We can also call this as a frequency curve. This is the frequency curve. And if we fill this frequency curve by any color, we can call it as a density plot. The density plot over the histogram is the next topic. A new window is generated and a 2 by 2 split of the window is to be performed, and then the density plot for the CNG cars. Car prices, probability is equal to true, histogram. This will be the car prices histogram of all car prices. All car prices means what? It is not for only for the CNG cars, it is for all cars with the probability is equal to true. Probability is equal to true means the density plot will be, which is the next command, the density plot will be generated over this histogram. This is the next plot by the lines command. It is not a straight line because I am using the density plot of the prices, and the line width is 3. Density plot for the CNG cars, so we can identify CNG cars. The car prices, car DF, fuel type is equal to CNG. So this is very important. This is. We put a condition over there in the car DF. If I eliminate this square bracket, then all prices will be used. In the square bracket, I have identified as fuel type is equal to CNG. Means the prices of the CNG cars will be used only. We cannot use the formula which we used previously with the box plot, in which we use fuel type here, and the price here. This is not allowed in the histogram. That is why we are using the manual conditions here. This is a condition. The prices will be used only for those cars which fulfill this condition. That condition is that the fuel type is CNG. So the first graph of entire data, the second graph is for the data of CNG cars. Similarly, I can change this CNG car to diesel. Another graph will be generated. Then CNG cars with the petrol. So we can generate total graph with the remaining graphs, right? The total graph can be displayed with the remaining 3 graphs. And this is a correction. This is not the command for the CNG cars. This is the command for all cars. And this is the command for the CNG cars only. Then lines and a density is generated. The histogram is generated. Then a density plot is generated. Again, the histogram is generated for CNG cars and a density plot over that. Similarly, two more commands are what? Diesel and petrol. So this is the diesel commands and petrol command. So you can see that these are the 4 different commands. By these 4 commands, we have the 4 histograms, and all over the 4 histograms, the density plots will be superimposed, means overwritten. So you can see the output by the different colors. It is the histogram of data of all prices. This is for the CNG cars. It's more look like as normal. It is for the diesel car and it is for the petrol car. So you can see that the CNG car is most likely normally distributed. Have prices. Prices are approximately normally distributed for the CNG cars, but it is right skewed for all cars. It is also right skewed for the diesel cars and for the petrol cars. The next element is the box plot for prices per year. It was the box plot of prices for different types of cars, but next graph I want to generate. The box plot will be generated with respect to the years. Year by year. The prices are increasing year by year. And we want to check what is the price increasing factor. At what rate the price is increasing. So these different box plot will give us a clear-cut idea about the increase in price per year. Firstly, we want to find out the unique years by one command. Caref dollar MFG year. MFG year means manufacturing years. Minus 1997. Why I put minus 1997? Because the first car in my data set is from 1998. So if I subtract 1998 minus 1997, the value will be 1. The unique numbers will be generated. What that unique numbers will be? Either 1 or 2 or 3 or 4 and so on. If the car was manufactured in 1999, the value will be 2. If the car was generated in 2000, the value will be 3 and so on. So why I am generating these unique numbers? Because I will use these unique numbers as color number. Color number 1, color number 2, color number 3, so on. So as many colors I have, as many years I have, unique colors will be generated by this command. And formula is again used here. Instead of using different conditions, we are using formula here. So very simple command it is. It will generate multiple box plots for each year of prices. Prices for 1997 data, prices for 1998 data, and so on. And the very important element is color is equal to my color. This is my color variable. This, it doesn't have anything. It doesn't have only 1, 2, 3, 4, 5, so on. So as many years I have, as many sequence numbers are generated. This is the output. You can see the 1998 is the first year. The color number will be 1, which is like light blue color. Then 1999 we have purple color, and so on. 2000 we have color number 3, and so on. So you can see that there is a increase in price year by year. This is the increment in the price. Can I call it as a linear increment or a non-linear increment? So clearly it is a non-linear increment. Means the prices are drastically increasing. If it is linear, the graph should be like it. If the prices are increasing in this pattern, we can call it as a price increment is linear, but in the actual graph, the price increment is not linear. It is some look like as exponentially growing. This was the element of identifying the graph for one variable. From the next slide, I want to describe the analysis referred to as bivariate analysis, in which the two variables at a time will be used for the purpose of graph. The bivariate analysis. The very important thing in a bivariate analysis, finding the correlations between the two variables or finding the relationship between the two variables, but numeric variables are to be used. Numeric variables are to be used for the purpose of identifying the relationships. So all variables in my data frame, which has 39 variables, are not numerical variables. So I have to identify only the numerical variables which are quantitative in nature. So which variables are quantitative in nature? So you can see that these variables are quantitative in nature. Column number 3. Column number 3 is the column of price. Column number 4, I think so, it's the age of the car, and so on. Some column is kilometer and horsepower. These are the different variables which have color, so which has quantitative in nature. Row numbers is blank. Row number is blank means all rows are to be used, but only these columns. All column will not be used. There are 39 columns, but I am not using 39 columns. Only the selected column will be used for finding what? For finding the correlations. Correlation matrix. Correlation matrix is computed, and the correlation matrix is stored in our data frame referred to as correl. You can use any name here, but I use COREL, and R is capital. I already identified as R is a case sensitive language. So if I use R as a capital letter, then in all of my rest of the commands will be R in capital letter. So what will be the output of this command? It will generate the correlation matrix. In this correlation matrix, diagonal have 1. Why the diagonal have 1? Because it is the graph between price and price. It is the graph, sorry, not graph, I'm sorry. It's not a graph. It's the correlation between price and price. This is the correlation between the age and price. So column number 3, as I told you, column number 3 is the price. Column number 4 is the age. Column number 7 is kilometer. Column number 9 is horsepower. Metallic color. 10 is metallic color. 12 is automatic, yes, no. 13 is CC. 14 is number of doors. 3 doors, 4 doors, 5 doors. And 18 is the weight of the car. So these are the scaled variable which I use for the purpose of finding the correlations. Some of the correlations are positive, some are negative. Very important correlation is this one, indicating that correlation is minus 0.87 between the age and price. When the age of the car becoming high, means the car becomes old, the price of the car will be depreciated and the decreasing price we have. So this is an indication of a negative relationship. And the range of relation or the correlation should be from -1 to +1. -1 to +1. -1 is a very strong correlation. +1 is also very strong correlation. And if we have a correlation around 0, we call such correlations as negligible correlations, or we can call it as insignificant correlation. The bigger number are the significant correlation, and the smaller number, which is around zero, are referred to as independent variable or no correlation or zero correlation. These are the terms which will be used for the purpose. If you want to plot the correlations, then we can use one library, and that library is CorePlot library. So install.packages, and package name is CoRRPLOT, CorePlot. Library install and then library initiate. These are the two commands which we will use. And the next command is CorePlot command, which plot all the correlations calculated in the data frame COREL on the previous slide. This is the CorePlot. This graph is indicating the correlations from -1, very strong correlations, +1, very strong correlation on the positive side and the negative side. And then around 0 is no correlation. And in between 0 and 0.2 is also called negligible correlation or a very weak correlations. So what these circles are indicating, the bigger circle means the higher correlation, the smaller radius of the circle indicating the weak correlation. The one important thing is the radius of the circle. Second important thing is, if the color is darker, indicating the higher correlation. If the color is lighter, indicating the weakness of correlation. So this is the way of identifying the correlations in a graph. You can identify the half plot because all of the correlations are not important for us. This is the correlation between the age and the price. Similarly, we have this correlation here between the age and price. So these two correlations are identical, these two. So we should keep only the one side of the graph instead of the both sides, upper triangular either or the lower triangular. So the next command is identifying lower as shade, upper as pi. The left half will be, the lower triangular will be shade and the upper triangular will be pi by this command, mixed. And in the above command, only the lower part will be represented and the upper graph will not be shown. So the two outputs of these two commands will be, one is this, lower part only, the lower part only is shown. In the second output, the lower and the upper both are shown, but in the lower side, shades are there, and on the upper sides, pi's are represented. The pi is representing very high correlation, black, dark color with a very high correlation, positive correlation. and this is also a high correlation, and so on. The weaker color, the smaller pi, indicating the weak correlation. All the graphs, scatter plots, can be displayed by one command, and that command is called the pairs. So numeric variables will be used. Some of the numeric variable I am using here, third one, which is the price. The fourth one is the age, HP, and 8. Some of the commands I am using here. Only the scaled variable. You can see this is the graph between the price and the age. This is the price is decreasing when the age is increasing. The same graph we have here. These two graphs are identical. Similarly, this graph is identical as this graph. So only the graphs which are either in the upper triangular matrix is to be analyzed, or below lower triangular matrix to be analyzed. One side is to be analyzed, and we can skip the one side. It is also a negative graph, HP and price. If we have the more horsepower, the price is like it. And this is the graph which have a binary. These are the binary variables, only the two values. And the name of the, I think I can't see the name of the variable, but this variable, whichever it is, it has only two values because it is a binary variable. The one value is to be indicated here and the other value is to be indicated here. So pair command is the one of the simple way to identify the all of the scatter plots by matrix. Analysis of age and price. If we want to analyze the two variables at a time, one variable is age, other variable is price, the plot command can do that. Plot command of age, comma price. These are the two variables. Is a scaled variable, is also a scaled variable. Main means what? Main means the main heading or title of the graph, X label and the Y label. And the output is shown on the next slide. What scatter plot is indicating and what are the very important element of the scatter plot is a type of data visualization that uses Cartesian coordinates to display the values of typically the two variables for a set of data. The scatter plots are foundation tools in statistics for bivariate analysis. It helps us to identify the direction, the strength of the relationship. If we have closer points, means we have a strong relationship. If we have points which are away from each other, the relationship is weak. It can identify whether the relationship is linear or non-linear, or it can identify the bivariate outliers. So the next is the command which is right. So downloading slope means what? Inverse relationship we have. Strong association, why? Because the points are very close to the line, meaning that the strong relationship. Looking as linear, but we can have a slight curve here. You can either use a linear model or a slightly curved model. You can use. But I think linear model is more suitable as compared to the non-linear one here. No bivariate outlier, because if any of the point is here, this is referred to as bivariate outlier. If any of the point is here, this is referred to as bivariate outlier. All of the points are in the direction of the graph which are not outliers. any of the point is away from the direction of the graph can be treated as bivariate outlier. We can have the two more variables which are scaled, age and kilometer. Age and kilometer can also be identified by the same command. Just age and the kilometer heading is changed, and X title and Y title. The graph is this. As the age of the car becoming large, car becoming older, the odometer reading will be increased. Means the older car have high reading on the meter, and the young car means the new cars have a very less reading on the meter. This is a very new car. This is the very new car. So it has a very few meter reading. 00 means what? A very new car, which is not even driven over, not only 1 kilometer. So this is called 00. Now similarly, the age and the kilometer, we can use the color command as well, different colors, and colors with the fuel types. Fuel type is used as a color parameter. If you use the fuel type as a parameter, then we have the 3 different types of fuel. Green color is used for one type of transmission, and other colors are also be mentioned here. CNG car, as very few cars are there which have CNG in between that. So you can see that the third color is very few here. Purple color and the green color is mostly over there in the graph. So very important is correlation between these two is 0.5 between the age and kilometer. The next command is the heat map command. Heat map in base R provide a straightforward way to visualize the data values as a color within the matrix. You can use the heat map function to achieve this. First create the matrix of data, then use the heat map function to plot the data. This method automatically cluster the rows and the columns to the highlight the patterns and the relationship between the data. You can also use the ggplot command to generate the heat map. Heat map displays the relative intensity of the values in a matrix or the color. Commonly used, visualize complex data set and identify the pattern and the correlation and outliers. Similarly, the useful when dealing with the large data set. If we have a large data set, heat map can be used to identify the outliers as well as the missing numbers, and other thing can also be used, right? Heat map consists of the grids of cells which contains rows and columns. Geographical data can also be represented with the help of the heat maps. I am using the heat map for plotting the correlation matrix. The correlation matrix will be printed with the help of the heat map. So we need a matrix conversion here. This is called matrix conversion as dot matrix. In the correlation, all correlations we have here. Correlation between 3 and 4, correlation between 3 and 7, correlation between third variable and the 9th variable, and so on. Then heat map is generated. Similarly, the two commands are there. Dendrograms are mentioned here in the first command, and you can eliminate the dendrogram from the second one. So these are the two graphs. One graph is with dendrogram and another graph is without. Darker color indicating the high correlation, the weaker color or the lighter color will indicate the weak correlation. So this is the last slide of this presentation, and 2 lectures has been delivered in this series. One lecture was about the data munging and the data collection. This was the first lecture. The video was already provided to all of you. The second lecture was about the visualization. Thank you very much for this lecture. That's all.